I'm Cynthia Luke. I'm a new investigator and clinician scientist at St. Michael's Hospital. I'm going to talk about some of our work looking at cell death signaling pathways and unexpected roles we've found for them in adipose tissue that help us better understand diabetes so we can look for better ways to treat or prevent type 2 diabetes. Let me start out by asking you what tissue undergoes the most non-neoplastic growth in adults. So more and more we understand that adipose tissue is a dynamic metabolic organ. We think that in some people it outstrips its healthy expansion limit, and this can result in cell death, inflammation, and insulin resistance underlying type 2 diabetes. The work I'm presenting today focuses on caspase 8, best known for its important role in programmed cell death, but interestingly has been found to have other roles in different cell types. We started out by looking at caspase 8 in mouse models and humans with obesity and type 2 diabetes, and we found that caspase 8 appeared to be increased in adipose tissue. So we set out to study caspase 8 in inflammation and whole body glucose metabolism, and we hypothesized that deleting caspase 8 in adipose tissue might prevent cell death, decrease inflammation, and improve glucose homeostasis. To specifically study caspase 8 in adipose tissue and in a whole body system, we generated adipose tissue-specific caspase 8 knockout mice. We found that particularly in the setting of a Western-style high-fat diet, these animals had improved glucose tolerance and less weight gain. When we looked at their adipose tissue, or cultured adipocytes treated with a caspase 8 inhibitor, we saw evidence of decreased activation of apoptosis signaling and inflammatory NF-kappa B signaling. So to see whether these changes in NF-kappa B signaling were resulting in changes in glucose tolerance, we specifically activated NF-kappa B signaling in the adipose tissue of our knockout mice and found that this attenuated partially the improved glucose tolerance we were seeing. Overall, this data suggests that caspase 8 plays an important role in apoptosis and NF-kappa B signaling in adipose tissue, and knocking down caspase 8 results in decreased inflammation and improved glucose tolerance. I'd like to thank my small but hardworking lab, Dr. Mina Wu, who helped me start this work, and generous funding from the Banting and Best Diabetes Center, CIHR, Heart and Stroke Foundation, and NSERC. Thank you.